Okay, students, so this is page 102, and this is testing mu1 minus mu2 when sigma 1 and sigma 2 are known. We're going to be using a two-sample z-test. So we're going to assume that we know the population standard deviations and that we have sample means and sample sizes from both population 1 and population 2. It's important to note that these populations are independent from one another. Your hypothesis is most commonly set up as h0 is mu1 minus mu2 equal to 0, or sometimes you have this hypothesis, h0 mu1 equal to mu2. So either one is acceptable. However, in many texts you'll see this one, for the difference of the means is equal to 0, which implies that there is no difference, which implies that they are equal. The alternative hypothesis, you could have a not equal to sign, meaning they're not equal to one another, they're different from one another. You could have a less than sign, which would imply that mu1 is less than mu2, or you could have a greater than sign, which implies that mu1 is greater than mu2. If you're doing the critical value method, you would want to look up a z critical value. If you're doing the p-value method, you will want to utilize the two-sample t-test in your calculator. Test statistic, again for the critical value method, or if you're doing the p-value method by hand, is as follows. Since the difference of the means is always assumed to be 0, we just subtract the two sample means and divide it by the square root of their variances over their respective sample sizes, and add that together, and then take the square root. Your decision, of course, you would reject or fail to reject, and then you write a conclusion. Okay? In the next video, I will be doing an example to illustrate both the critical value method in these assumptions as well as the p-value method. So stay tuned for that.